All right, class, let's do our first sketch notes. So as you watch the video, fill in notes that we're writing down. Anything I write down, you should probably write down too. Remember, you can always pause the video or speed it up, whatever you need to do. But let's start learning these concepts. The first one is the scientific question. Now, in science, we're always asking a question, and then we're testing the question to perform an experiment. And in the experiment, we're looking for a cause and an effect. Cause and effect. So let's think of some examples. How does atmospheric carbon dioxide affect global climate change? How does pH affect the pH of a soil, meaning like how acidic a soil affects plant growth? So we can write that in. How does pH affect plant growth? A farmer would want to know this question because they want to know if their soil is too acidic to grow their crops. Another one might be, how many hours of basketball practice affect your points scored? So how does practice affect points scored in a basketball game? So these are just examples of scientific questions. And if you notice, there's always kind of two pieces. There's the cause and there's the effect. So let's look at an example from class. So we're performing this experiment, the spaghetti bridge experiment, and we have this apparatus. The word apparatus just means experimental setup. We got spaghetti over 2 desks with a cup and pennies hanging from the noodles. So what are some things that can change about this experiment? This is the concept of the experimental variable. Variable is something that can change. I think that's right here. Variables are factors or properties that can change. For example, a factor that can change is the loudness of your speakers. You can change that. You could change the force of a soccer kick. You can hit it lightly or medium or hard. You could change the volume of rocket fuel. You can add more liters of fuel, and that will make the rocket go to the moon or go to Mars or go, I don't know, to a black hole somewhere. You could change the mass of a planet. You could look at Earth, or you could look at Jupiter, a much more massive planet. You could think about the speed of a car is something that can change. Speed is or velocity, that's probably a better word to say. That's more physics-y. Velocity, that's something that can change. That's a variable. All right, back up here. What are some variables in the above apparatus? All right, so we have our scientific experiment. What are some things that we could change, or that could change in this experiment? Well, you could change how big the span is, how large the gap is. You could bring these 2 desks further away, and you could set up your noodles across a larger span. That's a variable. You could add pennies, and maybe the bridge collapses at a certain number of pennies, and maybe you remake the bridge, and then you add more pennies, and that's something that can change, is the number of pennies. That's something that can change. The number of noodles, that's something that can change. You could change that directly. You could add more noodles to your bridge. You can make a really big bridge. What else could change? You could change the length of the string. You can make this string really long. I don't want to redraw this little image here, but that's something that can change. So those are variables in this scientific experiment. Which variables count? Only variables that are quantitative, which means they can be represented with a number. In other words, they must be measurable. Only variables that are quantitative, which means they can be represented with a number. In other words, they must be measurable. Think of the word quantity, like the quantity of bananas. How many bananas you have? I have 6 bananas. That's a number. I can measure it by counting. I have 6 bananas. 1, 2, 3, 4, 5, 6. Fun. Okay, so types of variables. We got 3 types: independent, dependent, and constants. So let's start with independent. Independent variable. This is the one that you could directly change from one trial to the next. It is independent, which means it isn't dependent on another variable in the experiment. Most importantly, this variable is the cause. So independent variables are the cause in a scientific experiment or a scientific question. All right, so we got our spaghetti bridge experiment. We have these different variables: bridge span, how wide the desks are, the bridge strength, how many pennies until the bridge collapses. Your bridge will be stronger if it can hold more pennies. It'll be weaker if your bridge collapses when you add maybe 1 penny to it. That's not a very good bridge. Something that can change is the number of noodles in the bridge, the thickness of spaghetti. That's something that can also change. If you go to the store, you get a different type of spaghetti, and the length of string. Now, which ones of these can you change directly? Well, you can change how wide the bridge is. You could change the number of spaghetti noodles. You can add more. You could change the thickness of the spaghetti, going to the store, getting a different brand, maybe thicker spaghetti. And you could also change the length of the string. But this one is not one that you can change. That is an effect. If you have if you have more noodles, that bridge will probably be stronger, but the strength of the bridge, that's going to be something that you measure. This is our dependent variable. So independent variables, what you change directly, and dependent variables is going to be the effect or what you measure. So let's move on. The dependent variable. This is the one that you can't change unless you change something else. It depends on another variable in the experiment. You will measure this variable to see if the change in the independent variable causes a change in the dependent variable. The dependent variable is the effect. And we just went over this, but in this experiment, the bridge strength, this is the effect. How many pennies? That's not something you change directly. That's something that you measure. Okay, constants. In a scientific experiment, you change one variable, the independent variable, measure another variable, the dependent variable, and keep any other relevant variables constant. Okay, so let's think about that. You change one thing, you measure another thing, and then everything else must stay constant. And everything else that's relevant has got to stay constant. So in this case, when we're making this video here, let's pick an independent variable. I'm going to pick bridge span. So this is my independent variable in an experiment that I'm going to run. So I'm going to change how wide the desks are set up. And I'm going to measure how many pennies these different width bridges can hold. So this is my dependent variable. I'm going to change the amount, the width of the bridge, and I'm going to measure the number of pennies until the bridge collapses. Now that means that everything else must be constant. This is going to be constant. The number of spaghetti noodles, I'm going to keep it at 4 noodles. The thickness of spaghetti, I'm going to make sure that we're only using 2 millimeter spaghetti. That's going to be constant. I'm writing the C for constant. And the temperature of the room, you know what? That's just not even really relevant. The temperature of the room, that probably won't matter how strong the bridge is. It might, but that's not something that we need to write in a procedure. It's just not relevant. So remember that your constants need to be, you need to hold your certain variables constant so they don't affect your dependent variable. All right. So let's look at that experiment that we just came up with. We have a bridge that, I don't know, has a certain width, and then you build a bridge, you test it, and you do a second trial where you build a wider bridge. So you can see that we are running this experiment. How does bridge span, how big that gap is, bridge span, how does it affect bridge strength, or the number of pennies until the bridge collapses? So how does bridge span affect bridge strength? So there you have it. We have our experimental variables. We've identified the independent variable and the dependent variable. And we've put it all in a nice scientific question in that format. How does my independent variable affect my dependent variable? Perfect.